Okay, it's time we cover a blind SQL injection. So we already know what SQL injection is, we know how it works, and we know how we can exploit. But what is blind SQL injection? Well, let me show you. Let's navigate to our DVWA, log into our page, navigate to blind SQL injection, and if you remember how we actually managed to discover whether an SQL injection was present on an application or not, is we used a single quote. And once we entered that single quote, it would give us an error, or it would give us some error message, or possibly even the query itself where the error occurs. That's how we would know that this input is not really getting filtered well. If I click submit on blind SQL injection, nothing happens. It's as if this application is not vulnerable. Doesn't give any error. We can type anything with as many single quotes as we want, and nothing will happen. Any character that we input will just get processed by the application, and it will retrieve this same page back to us. So, does that mean that it's not vulnerable? Well, it could be, but there is also blind SQL injection, which means it's not giving us any error back, but it's still vulnerable to the SQL injection. Okay, but how can we figure out whether the SQL injection is present in this application? Well, let's try specifying the correct input first. So if I just type 1 and click on submit, it will give me an ID of admin. It will give me its first name and last name. If I type, for example, 2, I will get Gordon Brown, and so on and so on. So we can select one user ID right here, and we get one output back. Same goes if we, for example, try 1, single quote, or 1 equals 1, or 1 equals 2. Let's try it like that. So we only get admin back, but it could be due to 2 reasons. Reason number 1, it's not vulnerable to SQL injection, or reason number 2, that only this argument is satisfied. ID number 1 exists, but 1 is not equal to 2, so this part is not satisfied, therefore we only get the output for admin. But if we were to type 1, single quote, or single quote 1, single quote, equals single quote 1, press enter, we get all the users from the application. Now, we don't get their usernames or passwords, however, we do get all of them outputted right here. And this would be a good indication that there is a possible SQL injection in the application. Why? Well, because this application is not meant to output 20 users, it's only meant to output 1. And with this statement, we told the application we want the ID number 1, or if 1 equals to 1, and it gave us all the other IDs. And that is one of the ways that we can discover whether it has some vulnerabilities in the application. Now, how can you exploit this? Well, here is where the problem occurs. Exploiting blind SQL injection is much longer and harder than exploiting an error-based SQL injection. For example, here we can't really output the database name. We need to guess it, because we're not getting any output back or any error back. So, how can we go about guessing the database name, the table name, the column name, and all of that? First of all, to keep in mind is that it takes a lot of time to do that, so for the purposes of this tutorial, we will only show how we can guess the database name. To guess the database name, we can use an SQL-like operator. And you can find it on this page. It describes what exactly does it do. The like operator is used in a where clause to search for a specified pattern in a column. Since we don't really know how the database is called, or we do actually know how it is called, but only because we exploited it in the previous lecture. We know that the database name is DVWA. This is the name of the database. But let's pretend that we don't know it. We want to discover it by exploiting blind SQL injection. we could do it like this. We could type one single quote for the ID and database, since we know SQL has this database function, and then this like operator, which has the syntax of open single quote, then the letter that we want to use, let's go with letter A, and then the percent sign. What does this mean? Well, this line simply says that we're checking whether the database name starts with A, and this percent sign simply replaces all the other characters that could come after. So we're only checking whether the first letter of the database is A. Let's press enter. We get nothing back. Why is that? Well, it's because the first letter of database is not A, therefore it didn't give us any output back. If we were to type something like this, and database, and then we switch A with D, because our database does start with D, and we click submit, now we get output back. And now we would know that the database name starts with letter D. As you can already imagine, this can take a lot of time to guess. And we could use the help of burpsuit to do this. So let's go to burpsuit. Let's turn on the intercept. Let's type 1. And, oops, let me just type it in first and then I'm going to intercept. So 1 and database like A. Let's start with A once again, just for the purposes of showing how this would work in burpsuit, and then we intercept the request. Now we want to send this request to intruder. Let's click on that. We can turn off the intercept and go back to the intruder. We want to select the positions, and here we want to clear all of these positions. Find the letter A, which is right here, and then add a position to it, since that is the only thing that we want to use as our payload. Once we do that, we want to go to payloads, and here we want to load all of the letters possible. So let's just go A, B, C, D, E, F, G. And here I loaded all of the possible letters that could be the first letter of the database. So once we load all the letters, we want to go to options. And here in the grep match, we can clear everything and add, for example, admin. So if we find the word admin in the page, then we're going to assume that we found the correct letter. Why is that? Well, if we get the correct output, it will output this that has admin right here. Or matter of fact, just so we can get even clearer response, let's copy this entire string, which is first name admin, and let's paste it right here. Then we add it right here, and if our response finds this string inside of the HTML code, that means we found the correct letter. All we need to do right now is start the attack. And here it is. We already get our response. Letter D is checked. It has first name admin in the HTML response. It also has a different length of the response than all the other letters, as we can see right here. Now that we guessed the first letter, we would cancel this. We would go back to the positions, and we would first of all clear this, remove the A and type D. After we type D, we once again type A. Then we select A once again as the second letter, since we already guessed first. And now our command looks something like this. 1 and database like open single quote D A%. Now we're guessing the second letter. Okay? If I submit, this will once again not give any output back because A is not the second letter. So let's see which letter is the second one. We can start the attack. Let's wait for this to finish. And here it is. Letter V is the second letter. Now we can go on to the third letter. So the V, A. We once again select A. We start the attack. And here it is. It appears that W is the next or third letter. Let's add it right here. And let's add A at the end. Select A and run the attack once again. And we get the response straight away. A is the fourth letter. Now we got the full name of the database. Now if we try to type like this, and database like dvwa, submit, now we get the response back. And here we can see that this is the name of our database. And you will have to do this for every database name, table name, and all of that. So now you notice why this is much longer to perform and much harder. Nonetheless, we covered it, we know how it works, we know that if we don't get any error once we specify the input, it doesn't mean that there is no SQL injection. We can also try something like making the application sleep for 3 seconds, which is also an indication that there could be an SQL injection if the application does sleep for 3 seconds after our comment. Nonetheless, thank you for watching this lecture, and in the next video we're going to start off with XML XPath injection. See you there.